I forgot to do the intro. Such a smooth operation. Greetings and salutations. This is Hugh, the biggest YouTuber ever. And tonight, I'm not coming to you from my underpants. Yes, I'm freeballing tonight, baby. I promised you a highbrow live stream, didn't I? And I bet your brows are high in amazement right now. And that's the perfect introduction for our esteemed and intellectual guest, PhD Tony. How are you, Tony?
I'm very well, thank you. Highly privileged to be here on such an august occasion as you freeballing it.
Yes, and are you wearing underpants?
I can neither confirm nor deny the existence of underpants at this point. I'm going to let the audience's imagination run wild.
The tins of Glen 20 are a bit of a giveaway, though.
Yeah.
I got him to laugh. Great. Can I just check? Is your phone on silent?
Let me just. It did go off. It's not on silent, so that's a good catch.
Yes,
because I was talking with Erica.
Yes, you've had quite a day today. You've had your video with Gutsick Gibbon, otherwise known as Erica, dropped this morning, and later on this afternoon. Well, yeah, I guess roughly this afternoon, you had a bit of a run-in with Rachie.
Yes, and I kind of think that she got off lightly because I think she should have just been banned from the channel at that point. But, you know, whatever. The fight is running his own ship over there. Greetings to everybody who's joining us in the chat, by the way. I see Dora and Koo, Clive Wells, My Mum Bakes Cakes, The Snark. A wonderful crowd here. You're pulling them in. Daryl M, he's already there.
Yes, I was going to say hi to everyone in the chat, particularly to those people Tony mentioned, but particularly to my members, Dora and Koo, Daryl M. Is there anyone else here as a member? Just scrolling through, not spotting anyone. No. But thank you all of you for joining us. Yes, Dora's opening tabs like crazy because this is a highbrow Hugh stream. So we'll see what happens. We're going to explore your brain, Tony. It's going to be fascinating. Our inspiration, we'll do Rachie at the end if we bothered to do her at all.
Right,
but particularly, I thought the Rumpus said some really good things too, so we might have a talk about that.
Did.
But what I'm thinking about in particular is your video with Gutsick Gibbon. There's a link to it in the description if you want to go and check that out and subscribe to Gutsick Gibbon. I have, and I have been watching her for a while. She's quite fascinating. She's a fairly young person, but she's recently got her PhD in primatology. And her focus...
I thought she had her PhD, but I think she may still be a student. I'm not sure. But anyway.
She's close to it anyway.
Yeah.
She's highly educated, put it that way. knows more than someone like Rachie, for example.
Oh, vastly more. She's an extremely well-informed young lady and very competent in her chosen discipline, and it shows from the videos she puts together. So it was an enormous privilege to be to do an interview on her channel. I was just trying to sort of clarify some of the stuff that I think kills young Earth creationism deader than it already is. Yes,
Gutsick Gibbon's focus tends to be on young Earth creationism and how the evidence for evolution and other things, and which Tony was providing in terms of glacial isostatic adjustment, basically disproves the young Earth hypothesis. Now, I'm not.
Yes.
Yeah, everything they have basically gets easily debunked based on real-world observations. Now, I'm not saying that in a way to offend Christians in general. Young Earth creationists are a very small subset of Christianity. The vast majority of Christians don't believe the Earth is only 6,000 years old or anything like that.
Yes.
But for those who do, I guess I am trying to insult you because you're not based on reality, and that is what my channel is all about. And I think it's what Tony's channel is all about too.
Yeah. as I was saying to Erica, it's not a matter of what we want to believe. It's not a matter of what we want to be true. It's a matter of what the evidence tells us. And you can't look at the evidence that we have available to us and conclude that the Earth is 6,000 years old. So it's not. It's just a matter of objectively looking at the evidence without any preconceptions, which is what you should do if you're trying to be intellectually honest or you're trying to be scientific.
I just saw Dora's comment. Who better to have on other than someone who lived through the glacial periods? It's quite an insult, but it's quite a funny one.
It is quite a funny one. Clive in there calling me a geologist.
Ooh, yes.
Them's fighting words.
And just to be clear, Tony is a geophysicist, not a geologist.
Yeah. Not
the same thing.
They're not the same thing. And it is. I am somewhat flattered by the confusion at some points. When Erica was asking, so these are Precambrian sediments. Yeah, I guess they are, because I know exactly when the Precambrian was. Do I sound?
You didn't.
Do I sound credible?
Well, then she said a subcategory of the sub era, which I had never heard of before.
Ediacaran I have heard of because it has a very weird. It had very weird flora/fauna. It had very weird life forms. Some of them seem to have been fractal based. Some of them don't have bilateral symmetry. They have sort of 5-way symmetry to their bodies. So there are some very weird and wonderful things that were alive during the Ediacaran. It's an interesting period of Earth's history. Sadly, most of those organisms died out, I had heard of it, so I guess I'm not too mystified by it. But, yeah.
Did I hear you say a 5-way symmetry?
Yes, a 5-fold symmetry on.
Wow. What does that even mean?
There are. If you imagine sort of a 5-fingered starfish, for instance, something like that. So it would. There are basically 5 sectors to this. If you look at the organism from above, there are 5 sectors that are sort of the same. That's what that would mean.
Okay, cool. This is what I meant by highbrow stream. We're going to get into definitions of things that you've probably never ever thought of before. Simply because it's all rattling around in PhD Tony's head.
Because I don't have any sort of filter on it. I do notice.
I just realised I haven't got my spit guard on. Let me just put that on.
Okay.
That might make it a bit easier for you to hear me.
Yes.
That's annoying. Technical difficulties.
Rotational symmetry every 72 degrees. That's exactly right, Snark. A 5-way
dog would be. If you say, come here, which way would it go? Yeah.
Yes, exactly. A 5-way corgi.
Yes.
Yeah.
One corgi's enough. I got 2 of them. So the reason I wanted to talk to you about today, apart from the day that you've had, is that there was several interesting things that came up in Gutsick Gibbon that made me think of questions that I wanted to ask you, basically. And I think everyone else would like to hear the answers, to be honest.
Okay.
My first question was, where in the world, I mean, you're a geophysicist, so that describes the whole world, not just Australia. Where in the world have you been to conduct your research?
So I've been to Sweden, England, Italy, and for conferences I've been to North America. So the main areas of glaciation that we have are Scandinavia, what we call Fennoscandia, because it includes Finland and it actually goes a bit east of there. into the Barents and Kara Seas. So sea level there. The study of sea level there and the study of environmental indicators is actually, there's a long and storied history to it, and it's fairly seminal in understanding that there was a process of glacial isostatic adjustment, that there were these very thick ice sheets present, many thousands of years ago, and that they depressed the land on which they rested, and that land is still uplifting at about the rate of a centimetre a year, slightly less than a centimetre a year, but uplifting at about that rate. And so, Sweden's one of the areas. There are a lot of researchers we've worked with in Sweden, and a lot of sea level data that we collected. So I've been to Sweden. There was also a smaller ice sheet covering Scotland and Britain. They've got groups that study that there, and I've worked with those groups briefly. And North America, of course, had Canada in particular was covered by about an ice sheet that was at points 4 kilometers thick and that was most of Canada and a large portion of the United States. So this was a genuinely massive ice sheet, and obviously the rebound caused by that is still ongoing. So there's still relaxation, and there's a corresponding gravitational signal and a corresponding deformational signal. Yeah,
we'll get into the gravity of it as well.
Yeah, Rob Slide points out that there's still tilting going on in the UK. There's still rebound going on there, and because the British ice sheet was smaller, there's what's called a hinge point. So there's the ice sheet pushing stuff down, pushing down the crust, and there's a bulge that forms on the outside. It's called the peripheral bulge. And there's sort of a hinge point in between. So the land will appear to sort of tilt about that hinge point. Anyway. Okay.
So one thing that occurred to me, a question to ask, was that you showed a graph or diagram, at least, basically Hudson Bay in Canada was like ground zero for the glacier. So it's probably the bit that needed to rebound the most.
Yeah, exactly.
When will that stop? The rebound stop? Is it a process of several million years, or?
So I mean, ultimately, it will keep on going. It will just get smaller and smaller and smaller until it becomes imperceptible, basically. But it will still by another, if it's allowed to relax for another 10,000 years, it will be completely relaxed. So it'll return.
Oh, okay. Only 10,000 years.
It won't be completely relaxed. Sort of, it's one of those things where you get a sort of an exponential return. So it sort of slowly returns to. But by 10,000 years from now, it'll be indistinguishable. You won't be able to tell that there's any uplift occurring, really.
Right.
So one of the problems that we have is that the Earth, everybody thinks of the Earth in their everyday experience as being this, stable, stationary thing that, there's no problems defining what sea level might be, or, going back there tomorrow. It'll be the same as it was today. And when you look in detail at what's going on, that's absolutely not true. Stable, the word stable, it really depends on sort of what time scale you're looking at and what purpose you're trying to define stable for. Because really, ultimately, nothing's completely stable. Everything's a little unstable.
Yeah. Yeah, especially on the millions of years timescale. So in regards to Hudson Bay, what would be the prediction? In 10,000 years, will it still exist, or is it just going to be shallower, or what?
It'll be shallower. I think Hudson Bay is deep enough that it's not going to be. It's not going to disappear completely, but it will certainly be smaller than it is now. So the shoreline's going to, and I showed images today of sort of the shoreline being a great deal inland of where it is now. That was when the glacier was still present, that those formed, but you'll be able to see the shoreline will retreat into the bay. Basically, that entire basin will continue to go up, and the shoreline will retreat. So Hudson Bay will become sort of smaller and shallower over time.
Have you been there at all, or?
I haven't had the good fortune to be there, unfortunately. It is one of the places that I would like to visit, but it's not that easy to get to.
Because another thing that fascinates me is you're a boy who grew up in Australia, where we don't have a lot of glaciation. Basically, in Tasmania was the only place we had any glaciers, and I don't think you're from Tasmania. So, what got you interested in this particular subject?
Well, it was kind of good fortune. I started out doing, I got an honours degree in mathematics, and I was looking, after I finished my honours degree, I was looking for a job, in fact, and I got a job at the Research School of Earth Sciences, working as a research assistant for one of the finest geophysicists on the planet, a man by the name of Kurt Lambeck, who's had a very august career, and eventually that developed into me doing a PhD there. My honours topic was geomagnetism, so it was a toss-up between geomagnetism and astrophysics. So with geomagnetism, I had sort of something of a geophysical inclination, but also the mathematics that's involved in geomagnetism also applies to gravity, because they're both what we call conservative fields. So they're both defined by a potential function that obeys Laplace's equation. So so the mathematical techniques from geomagnetism apply equally well when you're considering gravitational potential. So, which is one of the primary indicators that we have of glacial isostatic adjustment is its influence on sea level, and that turns into a gravity problem because sea level is defined by the equipotential field of the Earth.
And gravity is basically your job, isn't it? Measuring gravity wherever you happen to be.
Yes. So, well, at the moment, my job is actually satellite gravimetry. So I've moved on a little bit, but still the gravity field. I'm developing techniques for working out trajectories for satellites to detect and produce models of Earth's gravitational field. So there's a company in Sydney that's developing what are called cold atom gravimeters, suitable for being put in satellites, and they're being very proactive about this. So anyway, that's what I'm up to at the moment.
I don't know if you have the slides available that you had for Gutsick Gibbon, and plus the picture of the gravitometer that you use available. You can share those if you like.
I do have them. Okay, just let me get them for you.
And welcome to Professor Phil Bell, one of the friends of the channel. Always good to see you here. We should do another live stream sometime.
Right. Well, it's always great to see Phil Bell.
I noticed the Snark posted a link to a YouTube video, but I don't know what that is. So can you tell me what it is, the Snark? I can't really do that while I'm on stream. I can't really look at it.
So to answer Paul's heart attack support, yes, we can tell how much it's rebounded, because when there are what are called sea level indicators. I'll get to those as soon as I get the slides up. But I've managed to find a video of the gravimeter and I'll just have to work out how to share my screen.
All right. So that link that Snark posted earlier is to his latest song. So feel free to check that out after the stream, obviously.
Okay.
Share screen should be in your StreamYards. It should be, let me see. Well, it should be down the bottom. The fourth one along. Oh, yes, you got it.
Okay. So what I'm going to show here is just where we're in the transfer part where the helium gets pumped into the liquid helium duo.
Oh, it's even you.
Through the transfer tube and down into the gravimeter. And Michelle gets completely obscured.
So can you just pause it there for a second?
Yep.
What are we looking at? This is the gravimeter, this blue thing.
The blue thing is
putting helium in it. Why is that?
Yeah, we're putting so it's a superconducting gravimeter. So in order for the superconductor to work, it needs very low temperatures within the duo. So we're pumping in liquid helium to keep the duo, in the 8 to 11 Kelvin range,
which is incredibly cold.
Yeah, which is incredibly
very low energy. Yeah.
So in order to that metal tube, basically what's happening, on the right of the figure, you can see the top of a liquid helium duo. Now what we're doing is we're pumping helium gas into that, which will force the liquid helium up into that metal tube, across and down into the gravimeter. So that's what we're observing there. This is the process, and this is the sort of maintenance that I'm called upon to do occasionally. So anyway, that was that one. And
so
let me see if
how does that make it work, though? How does that make it detect gravity?
So so what happens is that there is a niobium ball sitting in an electromagnetic cradle, a magnetic cradle.
Niobium is a magnet, isn't it?
Yeah, that's right. So it's a highly magnetic ball. Now, if there's any acceleration of that ball, it'll try to move. But as soon as it moves, it'll induce a current in the superconducting coils that will push it back to where it came from. So because superconductors is involved, in fact, the ball won't move anywhere, but the current will change. The current induced in those coils will change. And from analyzing the current, we can analyze the accelerations that the ball is experiencing as a function of time. But in order for those superconducting coils to remain superconducting, they have to be cooled down to the temperature where superconductivity holds. So that's what we use the liquid helium for, is to keep the temperature inside the gravimeter.
So for those who don't know what superconductor means, can you just explain that?
So a superconductor is basically a material that has no resistance to electricity passing through it. It's basically zero resistivity. So it's very, very conductive, and it will, which is why as soon as the ball's moving inside an electric field, that generates an electromagnetic field in the ball, which in turn generates an electromagnetic field in the superconductor. And the superconductor is so sensitive that it's just going to instantly respond and apply a force that will that will sort of shove the ball back into its assigned position. So sort of that's a very coarse and unsophisticated way of describing a superconductor. I'm sure a material scientist would do a lot better. But yeah.
I'm sure that helped people understand a bit, though, as to why it was important. And this thing's so sensitive, it's probably one of the most sensitive ones in the world, I imagine. It can detect the gravity effect of your personal mass as you enter the room.
Certainly it can, but also it's sensitive enough that simply the vibrations of us moving around inside the room are a big problem as well. So it would us walking into the that room where it's stored is enough to throw it off for many hours. And we have to record every time we go into that room. Even we record even when we're in the outer room where sort of the monitor is kept. But generally, sort of we try to interfere as little as possible with the operation of that instrument. But every now and again, we do need to go and manhandle it a bit and pump some liquid helium in. But yeah, it is an extremely sensitive machine. So it's buried in a basement, but it can detect the gravitational signal due to thunderstorms, for instance. So if there's a large-scale air pressure change outside, it will detect the gravitational signal because of that. So
I imagine it picked up the Tongan volcano then, when the air pressure waves came through.
Yes, it would have picked up. It would have picked that up. I think that it's got a temporal sampling that's good enough to do that. And I'll just bring up the other.
Could you just ask before we move on to the Gutsick Gibbon stuff? So what sort of things? It's in Canberra, right?
Yeah, it's in Canberra.
Or as Peter Harvey would say, Canberra. So what sort of gravitational perturbations does it detect there in Canberra? What is Canberra particularly stable or unstable, or what?
Canberra is theoretically one of the most tectonically active places in Australia, but we've got sort of several faults that occur nearby, but we don't experience many large earthquakes.
Called Parliament House.
Well, that's certainly a fault, but but most of what it does is analysis of tidal signatures and seismic, and remote seismic signatures, so it's not necessarily wise to look at it as an isolated instrument, because what we do is, what happens is that this instrument's readings are coalesced with a bunch of other instruments. And so they can tell something, if, for instance, you've got a particularly large seismic event where you can have seismic waves. Basically, for a large enough seismic event, the Earth will ring like a bell for a long while afterwards. And those vibrations actually cause gravitational signals deep inside the Earth. And we can use those gravitational signals to tell us something about large-scale internal structural features of the Earth, for instance, the density profile and that sort of thing.
Well, it's something I want to get onto later. But can I just, if you can just indulge me for a second, my dad was in the airlines, and back in the days of 727s, Canberra is a place where it'll be 40 degrees Celsius in the summertime and 0 degrees in the wintertime.
Yes.
It's these massive changes in temperature. And in the summertime, it's also built in a kind of what Australian geologists call a pound. It's like a bowl. There's mountains all around it, and the airport's in the middle in the deep bit. It's not really a valley. It's well, I guess it technically is a valley, but it's kind of like an area surrounded by mountains, almost a caldera, I guess, but it's not a volcano. And my dad was in the airlines, and he said in the days of the 727s, if the temperature got over 40 degrees, they'd have to cancel flights because they just didn't have enough lift to get over the mountains when they took off, because the air density was so thin. Is this can this machine detect the effect of the difference in the air density as a result of temperature, perhaps, or
for a large enough change in temperature? Yes, it certainly would detect that sort of thing, which is why it's able to detect, for instance, storms. So large scale density changes like that, yes, would show up in the most probably at the seasonal on seasonal wavelengths. You would certainly get a signal showing up there. But the instrument is certainly sensitive enough to detect that sort of influence.
I don't know if it affects 737s, but maybe Qantas needs to know about this too.
Might do.
I'll leave you to go on to the presentation you had for Gutsick Gibbon.
Okay, so yep. So here, for instance, this is not Hudson Bay, but it's the Bathurst Inlet. It's reasonably nearby, and you can see the retreat of the shoreline as as uplift progresses. You can see that there's sort of a succession of beaches.
What time scale are we seeing there?
So this would be on the order of 10,000 years, I think, for this particular. I'm not exactly certain, but certainly,
I thought 10,000 years it would have eroded a bit more than what we're seeing anyway.
Well, I mean, you can see that there's a filthy great river that's carved its way through the middle of it. So, and you are in Bathurst, you are sort of on the very northern coasts. So this is a very Arctic environment.
Lots of snow.
Yeah. So you may not get erosion may not take the form that you usually usually imagine. But I don't have precise dates for this.
That's all right. I was just asking on the off chance.
Yeah. Same general area. You can see the sort of trees. What happens is you get these sort of strips of sand and interspersed with sort of what are best described as boggy bits that actually have soil. And so they form these bands where trees are happy to grow in sort of the stuff that has fertile soil, but aren't so thrilled by the concept of sand. So these rings here tend to follow those geometries. Well, actually, if I go a bit further in you can see these sort of from above in this image here. You can see the sort of the various sandy bits with with sort of quite fertile regions in between. And here you can see sort of the same sort of thing. So yeah, these are just some of the sort of the paleo sea level indicators that we look at.
Yeah, I mean, like I said earlier, in Australia we don't see a lot of glaciation, and when I lived in the UK, you see a lot there. Pretty much any mountainous area in the UK is based on glaciation. Volcano as well. You've got the Giant's Causeway and things like that. But a lot of glaciation whenever you get up into the mountains there. So in Australia, we don't see this sort of thing generally. We're more. In fact, that's one of the questions I have for you. What would be a geophysicist's view of Eastern Australia, given that basically the Great Dividing Range, which stretches from North Queensland down to Victoria, was formed by a volcanic hotspot, much like the way the Hawaiian Islands were formed. And that hotspot's in Bass Strait now between Tasmania and the mainland. Is there anything more to say other than that as a geophysicist of Eastern Australia?
As a geophysicist, Australia's actually quite old. So the Great Dividing Range is a very old mountain range, which is why it's not anywhere near as high as many of the other mountain ranges that we see. And if you go through the Blue Mountains, you'll see just how sharply eroded it is. So it's a very old feature. But it's Eastern Australia is also geologically complicated because it's kind of bits and pieces that have been grafted onto the eastern end of Australia. The oldest portion of Australia is in Western Australia, and in particular, sort of southwestern Australia, where you can find zircons that are, about 4 billion years old. So these are very archaic geological structures. Eastern Australia is newer than that, but it's basically the result of things coming in and colliding with the eastern edge. But geophysically at the moment, I wouldn't describe Eastern Australia as necessarily that interesting, though it is useful in terms of sea level indicators, because there's the Great Barrier Reef, which provides a great deal of sea level data that we can use to that we can analyze. So there's also another element that we can, if I go, for instance, to this slide, if you look at the curve for Andoya, you can see how these are relative sea level as a function of time. The central panel there is Andoya, where you can see sea level falling, and then it goes up again, and then it drops down. That spike there at 6,000 years, that's actually fairly typical of what we call far field sea level indicators. So sea level indicators that are normally far from the ice sheet. The reason it formed here is quite complicated, because this is a near field site, but it's a good illustration. Generally in Australia, they're smaller. This one has an amplitude of about 8 meters. Normally in Australia, you'd find 3 to 4 meters. But that sort of thing would be the mid-Holocene high stand, or the Holocene high stand. And there are a couple of factors that go into creating that effect. But it's very pronounced in sort of northern New South Wales, and moving into Queensland, you can see this high stand, but it disappears as you move down towards Tasmania. And that's actually a little bit interesting as a geophysicist, because that can tell you something about the size of the Antarctic ice sheet, which we don't have a lot of data on, because there's not a lot of opportunity for glaciological evidence or sea level evidence to form. So we don't know much. We can't tell much about the Antarctic ice sheet at through the last glacial cycle, because there's not a lot of observational evidence. So even though it seems very indirect, teasing out signals from the east coast of Australia, it's actually quite illuminating from our perspective.
Can I just point out something here? Because this is something that flat Earth idiots and other reality deniers don't seem to understand about science. I'm not seeing it on Andoya, but on southwest Finland and on Jaren, I guess that's the way you pronounce it. Both those, each of these points aren't a single data point, as indicated by this line with a circle in the middle and defined ends. That has to be a data set, a set of data points that were collected. The circle will be the mean of that, and the extremes are indicated as well. So
normally that would be the case, but in the case of sea level indicators, you need to be a bit careful. That can just be a particular sample. So, for instance, if we find an in situ shell of a bivalve, or a piece of or some coral that is growing in, that is clearly in the position where it's grown, well, that tells you that sea level was higher than where you found the coral. So that puts an upper limit on where sea level could be. But also, these corals only have a certain range in which they can grow. They won't grow too deep because they don't get enough light. So you know that it must have been shallower than this lower limit. So this is just one example. But from the one coral sample, there's an upper limit on where sea level could have been, and there's a lower limit on where sea level could have been. So normally what happens with these sea level indicators is those are error bars. Your sea level curve must go somewhere between those error bars. So that's what's normally going on there.
That's exactly where I was going, actually, Tony. I was going to point out that this is a margin of error analysis, effectively.
Yeah, that's right.
Which is something FLIRTs never do. They find the outlier in a set of data and pick that as, oh, yeah, sure, that's the proof, and everything else is just an outlier. They do the exact opposite of what they should do. You need the margin error analysis to determine how good your data is. If you've got a large margin of error, then your data is not that great. But if you can specify what it is and you can see a trend base within that, that means your data is pretty good generally.
Yeah, that's right. So you'll notice the Andoya data set does have error bars on it, but the error bars for those are actually quite small. You can see them sometimes, but largely they're obscured by the circle. So yeah, that's a particularly good sea level curve, whereas the other ones are less well constrained. But that's it's it does very much constrain, and this is one of the problems that we have with GIA is that we can't control where there are sea level indicators. There are sea level indicators where there are sea level indicators. That means that the sea must have had access to it. The sea level indicator must have had an opportunity to form and must not have been destroyed by any subsequent events. So our set of sea level indicators is geographically limited and temporally limited, because obviously when a thumping great ice sheet comes along, it's going to destroy the opportunity for sea level indicators to form, because it's there and the seawater can't get in to make a shoreline. So you've got a very restricted data set, and trying to you fall between two. You are caught on the horns of a dilemma. Sorry. You have to respect the data. You don't want your model to be going too far beyond what you can reasonably say from the data. On the other hand, you don't want to be so loose in your conclusions that they're essentially useless. So yeah, it's difficult, and that's why sort of not everybody does it, which is something that flat earthers also and anti-science activists of all sorts don't get.
Morons is the appropriate term, not activists.
Yeah, moron. Just to answer Dora Uku's question, her highbrow question. Huffing helium is not really approved by occupational health and safety. They don't tend to like us doing that, and if we so no, we don't. We're not allowed to use it for sound effects.
Yeah, you can't actually breathe helium. You can breathe it in, but it's not going to give you any oxygen. So you can suck a balloon in, fine, and talk silly for a little bit, but don't keep doing it, because it means you're not getting oxygen, which means you're going to suffocate.
It's actually somewhat dangerous as well, because your body is designed to detect high levels of carbon dioxide, but it won't detect high levels of pretty much anything else. And it won't detect a lack of oxygen. Your body doesn't detect a lack of oxygen. It detects an excess of carbon dioxide. So if you're breathing helium, if you're breathing an inert or gas or anything else that you can't breathe, nitrogen, for instance, your body's not going to tell you that you're not getting any oxygen. So you're not going to know that you are asphyxiating. So it's there are some reasonably. Let's just say that I've had to sit through some health and safety lectures about this. Anyway.
Yes. Yeah. So yeah, it's fun to do it with one balloon, perhaps, but don't. Give yourself 5 minutes till the next one if you're going to do it. Don't. And what you're saying about the body not detecting, obviously the body doesn't encounter large amounts of helium in nature, so it never needed to detect that.
Never needed to do that. So yeah.
Got another slide for us? Do you want to talk about it?
Yeah, I'm quite happy.
I have more questions, but I'll keep going with you though.
This was actually an interesting case. I didn't mention it on Gutsick Gibbon, but we were actually called in. So this site was in the south of France, and this is a cave that's whose entrance is now 37 meters below sea level. But inside the cave, there are these quite fantastic cave paintings. And there are two sets of it. Here we're seeing the later set, which dates from about 19,000 years ago, which detail animals. The earlier set, which are from about 27,000 years ago, are basically handprints. So they're very similar to sort of some of the Aboriginal handprinting stencils that you get. When these were found, there was originally a suspicion that they might be fake. And one of the reasons for that is because you can see that these are very close to the water. And if you recall what I was talking about earlier, people were saying, well, there should have been a mid-Holocene high stand or a Holocene high stand that should have erased these pictures to higher than this level. And we were able to do modeling that suggested that actually in this region, in the northern Mediterranean, you don't get Holocene high stands. If we go back to just the sea level curves, sample sea level curves that I was showing you before, in these areas you get sea level curves that look more like that northern sea level curve. So they don't have high stands. They just come up to modern sea level from below. And the reason for that has to do with the gravitational signal of the Fennoscandian ice sheet. But actually my group was sort of approached to sort of do the modeling for this and to determine whether or not it was plausible that this was a real site. So that was actually quite interesting.
So Clive Will asks if any of that artwork was portraits of a young PhD Tony.
I have no artistic talent whatsoever. I was quite envious of the people who painted it, but no, I couldn't produce anything that fantastic. Let's be real, Clive.
Whereabouts in the world were these caves?
So these were in southern France. So
right. Okay. So it's the famous ones.
Yep.
Yeah. You can't actually go to them anymore. They've got a replica cave you can go to, apparently.
Oh,
but,
okay.
Yeah.
I didn't know.
Obviously, a scientist like yourself could go into the real ones, but yeah.
No, with an entrance at 37 meters, that's getting down to the limits of your average scuba diving certificate.
Yes. And then you have to swim up the cave.
Yeah, the
and
other.
You got to remember. Sorry, Tony.
Sorry?
Just let me interrupt.
Yep.
The other thing about painting these caves, you can see how far inland, well, up the cave it was. All they had was animal fat torches,
yes.
and yet they went to all this effort to make this art inside this cave.
Yes.
And I don't know how far that distance is, but that's I would guess it's looking at the scale, it's 100 meters, something like that. So they've gone out of their way to find a dark place deep inside the earth, which I would have thought was fairly scary to a primitive man, and and then spent hours painting all these artwork, which is just incredible to think about, isn't it?
It is. It is quite sort of a disorienting situation to consider, but these provided secure environments away from bears and other large predators, and they were easily defensible.
Drop bears,
and drop bears too, and sheltered from the elements. So they presumably were quite desirable as residences. So you can see why people would put effort into sort of preparing them, and oftentimes, I'm not sure, we tend to view things from the viewpoint of people who have access to electricity. And when you don't have electricity, a night is a long time, right? You've got a lot of time to kill. You can't sleep
especially in the winter.
Sleep after dawn, especially during winter. So you come up with things to fill that time. one of which will be, perhaps drawing pictures with coal or with other pigments. So it's easy to understand why this was a systematic feature of early human behavior, but it's still remarkable from a young Earth creationist timeline. However, this cave must have been inhabited post flood. So this must have been post flood, but there were still significant ice sheets present. But the artwork inside the cave doesn't bear any resemblance to anything that was being drawn or presented or preserved in the Middle East. So this is, you're presumably saying that the young Earth creationist position must be that these paintings were painted by relatively close descendants of Noah, but they have no cultural similarity to anything that the tribes in the Middle East were doing at 5,000 years ago. There's no material similarity. There's no stylistic similarity. And they're thousands of kilometers away from the Middle East. So what you're saying is that basically Noah's many descendants apparently sprinted as far as they could and started painting, rather than painting the stuff that, they'd painted while they were on the ark or whatever, they started painting, cave paintings that were in vogue many thousands of years earlier. So it's not a hypothesis that makes a lot of sense. I would guess that it is pre-mud flood as well. Yeah.
Yes. Well, I was going to say, not only about Noah's descendants, things like kangaroos, wombats, emus, they hightailed it for Australia. They didn't stop anywhere on the way. They went roughly 10,000 kilometres to get to Australia and therefore stayed there, and there's no evidence of them between here and Mount Ararat.
Yes, well, that would seem mildly problematic, but you've left the one off there that I am most dubious about, which is koalas, because in addition, koalas aren't the fastest things. So getting from the Middle East to Australia can't have been easy for a coterie of koalas. And what did they eat? In fact, what did they eat while they were on the ark? Famously, koalas only eat eucalyptus leaves.
And particular types of eucalyptus as well.
Yeah, particular type of eucalyptus leaves. How do you have fresh eucalyptus leaves for a year?
Yes,
you can't eat the
Middle East.
Yes, sourced in the Middle East. And what did they eat during their trip back to Australia?
It's a miracle, obviously.
Yeah, it is such an idiotic hypothesis. Anyway,
I love the dinosaurs were on the ark theory, because to me that means at the time the ark settled on Mount Ararat, the only thing left would be a very fat T-Rex.
That would be about all that would get off. A very rotund, very satisfied looking.
A huge ass type of T-Rex,
yes.
I guess. So, yeah.
So, and here's what I think is...
Sorry? I just wanted to say welcome to Truth Nerds, one of my members. So good to see you here.
Yeah. Yes, good to see you. And this is what I think is one of the strongest evidences against the young Earth is these snowball phases. So what you're looking at here, IRD stands for ice rafted debris. So what happens is that underneath the glacier, you get this fine silt mud that gets discharged, forms this very clayey layer, and then these rocks get carried off in icebergs, and then they get dropped into the mud. And you can see that happening. That's this ice rafted debris here, and you can see it's a very thick layer of mud. DF stands for debris field, debris flows. So that's and on the top is a capped dolostone, which is a carbonaceous formation.
So explain the capstone bit. How they came to form.
So what happens during these snowball events is that you get runaway glaciation. Glaciers start forming, and because they're so reflective, they reflect more of the sun's energy into space, and the surface of the Earth gets cooler, and you start getting more and more glaciers. The only way out of that is for enough carbon dioxide to accumulate in the atmosphere that it makes the greenhouse effect stronger and melts all of the glaciers. But as soon as you've done that, you've got this carbon dioxide in the atmosphere and very little carbon dioxide in the ocean. So the oceans instantly start sort of absorbing carbon dioxide, and over thousands of years, they start depositing it as this carbonaceous capstone, this capped dolostone. So that's why you always get these carbonaceous capstones on top of these glacial deposits, is because this sequence repeats. And so that's the result of carbon dioxide that is dissolved into the water, and then it's precipitated out as calcium carbonate. So that's what's happening there.
So, how much carbon would have to be in the atmosphere for that to happen?
Quite a bit,
I should say.
Yeah. I think it's
400 parts per million, or
many times, much more than that, because albedo was higher. So you need to more than compensate the albedo. Albedo today is not that. Albedo in albedo on a snowball Earth would be close to 1 for all the glaciated regions. So
albedo, for those who don't understand, it's the amount of reflectivity, I guess you could say. Snow reflects light. So so if there's many times more, what was generating that much carbon dioxide in the atmosphere? Was it volcanic, or was it other things?
It was just volcanic. It was which would have taken a while. So it would have taken a long time to accumulate the carbon dioxide in the atmosphere from volcanic emissions. And this is one of the things that is not generally well understood about the Earth. For instance, based solely on the energy Earth receives from the sun, the surface of the Earth should have a mean surface temperature of minus 18 degrees Celsius, based entirely on the energy we receive from the sun. The reason we don't see that at Earth's surface is because of the influence of greenhouse gases, in particular carbon dioxide and water vapor, and to a lesser extent
as well. The Gulf Stream and all that.
Well, the Gulf Stream transports heat from one region to another, but the reason for the warmer surface temperature, if you throw a satellite into space and you look at how much you look at the energy that Earth is radiating, it does indeed radiate at 255 Kelvin, at minus 18 degrees Celsius. So that's the temperature at which it radiates infrared energy into space. But the reason for that is that the atmosphere is opaque to infrared, so the satellite can't see down to the surface. It can only see down to what's called the effective emission altitude. So the greenhouse gases we have provide that 33 degrees difference between what it should be based on solar energy and what it actually is. So it should be minus 18 degrees Celsius, but it actually is 15 degrees Celsius. But for large portions of Earth's history, Earth has been frozen. It has been a snowball because there wasn't enough greenhouse gases. It's also worth pointing out that the sun has gotten about 30% brighter during its over the 4 billion years that Earth has been around, 4.6 billion years. The sun has gotten about 30% brighter. So it's a lot warmer now than it was back when Earth was newly created.
A few things have happened since then too. So
yeah, a few things have happened. For one, we've forgotten what shape the Earth is apparently. But if you look at if you look at these, just the scale of these things, like the Northeast Svalbard one, which is this one in the middle, down here, like that red stuff down the bottom, the diamictite, that's thousands of meters thick. Well, at least 8,000. So it's just absurd to think that there was a satellite, that there was sort of glaciers there producing this much glacial debris in what, a year, 2 years, even 1,000 years. It's absurd. Glaciers do not produce that much silt, finely ground debris that quickly. It's not a quick process.
I was hoping, when I asked you how much where you've been to with your job, I was hoping you were going to say Svalbard, because that's a place I'd always wanted to go to, but apparently you haven't been there. So, but you
I
have
haven't.
a few times in the video with Gutsick Gibbon. So.
Yeah, well, it's a very important place for glacial studies of paleo sea level and the Fennoscandia night sheet. But it's also got these deposits on it from the snowball Earth from the cryogenian age. And there was also the other thing that I wanted to discuss was cosmogenic exposure age dating. So
yeah, I have a question about that. So keep going.
Yeah. So here's an example where you've got a very energetic proton. It hits an oxygen-16 atom, produces helium-4, helium-3, and beryllium-10. And there are a variety of isotopes you can produce. Helium-3 and neon-21 both don't undergo any radioactive decay whatsoever. But there are a bunch of others that do. Beryllium-10, carbon-14, 20. In fact, this is how carbon-14 is created, is from the impact of cosmic rays on nitrogen, I think. 26 aluminium, 36 chlorine, and 39 argon. And you'll find that if a rock formation is exposed to cosmic rays for some time, then concentrations of these various isotopes will accumulate in the outermost layers. But if there's any erosion, then removing those outermost layers, then it'll go back to sort of showing a cosmogenic exposure age of 0 because there's no evidence there. So, we can use this to test the various hypotheses. So, if this is our starting point for the Grand Canyon, that top thing is where the erosion all happens at once. You should have pretty much identical cosmogenic exposure ages from the top to the bottom. Whereas if it occurs slowly, you should have older cosmogenic exposure ages at the top and younger ones at the bottom. And when you go and do the analysis, lo and behold, you see older cosmogenic exposure ages at the top and younger ones at the bottom. So the hypothesis that the Grand Canyon formed in a week is instantly dismissible.
Yes, and it's just looking at it from the point of view of a young Earth creationist, if God is perfect, then why did he create data that contradicts the 6,000-year theory?
Yes, that's exactly right. So it's not a matter of what we want to believe. It's not a matter of what we prefer to believe. It's a matter of what the data tells us. And just impartially examining the data, does not permit us to conclude that the Earth is 6,000 years old. We have many data sets that confirm that the Earth is much older than that. And whereas the young Earth creationists have a book of stories, and I can say that as a former Christian, I never had any great confidence in the literal validity of the early books of the Bible, in particular Genesis. It's just not a documentary. This is a sequence of stories that some ancient people wrote down, and a lot of them are actually, if you look into it, they're cheap knockoffs of Mesopotamian stories from the same problem, for the same era. Sorry.
Yeah. But yet it's fascinating that young Earth creationism is such big business. It's amazing, isn't it?
Well,
particularly in America, not so much of the rest of the world, but yeah.
Not entirely. Well, I would point out that Ken Ham, Andrew Snelling, these are all Australians. They live in the US now, but they are just Australians.
You want to hear something scary? Ken Ham grew up in Cairns in North Queensland, where my mum grew up, and he's of similar vintage. The scary thought is he could have been my dad, baby.
Well, you dodged a bullet there.
Well, I'm pretty sure he's not. So,
okay, I'm not going to take that metaphor any further. But it's not necessarily surprising in the sense that as religions develop, they become very efficient at corralling influence and money, so they become very influential, and they want to stay very influential. And so if religions that do not succeed in acquiring power and money and influence, they vanish. So there's sort of an evolutionary pressure on religions to actually turn them into money-making devices. And in this particular, in the particular setting of modern society, there are a lot of people who feel very threatened by the way society is progressing. They feel traditional family values are not being respected. They feel that religion is not being respected, and they feel very threatened by this. So they're very keen to buy into an ideology that tells them that science and rationalism and all of these fancy theoretical and rational arguments that sort of the younger generation are coming out with, you can just dismiss those out of hand. All you need is this book and what this preacher is going to tell you the book says. And a lot of people are finding that a very tempting way to go. It's not entirely surprising, but it is very disappointing that's happening, as far as I'm concerned anyway.
Yep. Monkey in the Works, another one of my members. Welcome to the chat of this live stream. Good to see you here. Religion doesn't deserve respect. Well, yes and no. I mean, because of religion, we have hospitals and we have the education system, and that's. I mean, in the end, it was really people that did it, but they did it for the motivation of religion. So religion's not based in reality, really. It's certainly not based in fact. It's a faith. That's the point of a faith. It needs to be respected in context, I guess. I don't think it can be rejected out of hand, put it that way.
Well, I would say the same. I would express what I think is the same sentiment slightly differently, which is to say that religion doesn't deserve withering contempt and ridicule per se. It only deserves withering contempt and ridicule where it directly contradicts observable reality. So If religion can steer clear of making any statements about observable reality that are demonstrably false, we can all get along. That's fine.
And I think most Christians, I don't know about other religions, but most Christians would agree with you.
Yeah, I think so. For instance, I have full respect for Dora's noodly inclinations as far as religion is concerned.
She's a pastafarian.
Yes, and also for Clive Wells, deification of squiggly maths. But the
Professor Bell's a pastafarian too.
Is he? Okay. Well, yes. That's good to know. There is an inclination for people to sort of, I think, if I'm being honest, the current culture wars that are going on come down to two things. One being abortion and women's right to choose, as far as their health and their mental health, their social health is concerned, and homosexuality or sexual identity more generally. People don't approve of homosexuals. They don't approve of transsexuals. They don't approve. They want everybody to fit into their nice little boxes. And I think we need to move beyond sort of simplistic labels for people and just accept everybody for who they are. Independent of whether or not they fit into a neatly defined box that my book says is okay. The same portion of the Bible that says that homosexuality is bad strictly enjoins that you can't eat prawns or crabs or any
wear
other
clothes with different fabrics. Yeah,
wear clothes with different fabrics or grow two different crops in a field. There are all sorts of bizarre injunctions that are punished by a capital punishment in the Old Testament. So working on the Sabbath, for instance, and it is bizarre to the point of pathology that people choose to pick these very specific examples from a larger corpus and completely ignore the ones that they just don't want to pay any attention to. Well,
not like flat earthers at all, is it?
Yeah.
Can I just welcome? I think I welcomed Monkey in the Works earlier. One of my members, but also Stringer News One. Welcome to the stream.
Oh, he's been there for ages.
Yeah, but I hadn't noticed him before. So I've been listening to you too much, Tony. I should chat occasionally. They are my audience, after all.
They are your audience. I suppose they deserve some respect.
Well, some attention, at least. I mean, I'm giving you a lot of attention because you deserve that too.
Oh, thank you.
Maybe I should move on to the next question. The magnetic field reversal is something that people are talking a lot about lately. What are your thoughts on that as a geophysicist?
So magnetic field reversals happen occasionally. I think the last one was 700,000 years ago. They occur. We don't know much about what drives them or why they occur. So they, we could be due for one. And certainly there's a great degree of polar wander that we're sort of currently observing. We do seem to be observing sort of increased activity. But I think that these processes are generally, relatively slow. I don't think that they're as instantaneous as people necessarily have hypothesized. On the other hand, there's not really much reason why they couldn't be. You could get very fast flow through the core. I'm not saying that it's impossible either. We just don't know that much. But the evidence we have suggests that actually life is fairly much uninfluenced by these things. So we're not necessarily going to notice that much, except where it impacts our technology. So this will impact our technology. It will. We rely on Earth's magnetic field to protect us from cosmic rays, for instance. And so if we do get sort of an oscillation or a wavering of Earth's magnetic field, you can expect increased cosmic ray impacts, and that may have that will certainly have consequences for our satellite networks and our high altitude technologies, certainly, and perhaps even for some ground-based technologies, depending on the severity of the incident. So I wouldn't consider it terribly concerning. I think that we can navigate our way around that. But the generating mechanisms for Earth's magnetic field are not particularly well understood, and we don't really know what causes magnetic reversals to occur. So predicting them is kind of just guesswork.
So it sounds like even if one happens, it won't make a lot of difference, except maybe to navigation. Is that right?
Yeah, it'll certainly make a difference to compasses.
Yes.
Yeah. It'll have some impact on compasses. It'll have some impact on some systems, I would imagine, particularly I think space-based systems, and it'll make us particularly vulnerable to space weather. So if there happens to be a coronal mass ejection, on top of that hits us on top of sort of a magnetic reversal, that could be really, really bad. That could well Stone Age humanity. A simple coronal mass ejection can Stone Age, has the potential to sort of Stone Age modern society.
The Flirts are already in the Stone Age, but anyway.
They are already, so no loss for them, but at least we won't have the internet around and won't have to hear from them. So they can go back banging rocks, which is all they're qualified to do.
Can I just understand the mechanics of that? So if the magnetic field reverses, does that mean we're not protected from solar winds anymore, or for a while at least, while things settle down, or what?
I think generally, I think the process is that the dynamo doesn't sort of rotate wholesale from the north to the south. The dynamo sort of weakens in the northward direction and then starts reversing flows. So the magnetic field weakens during these reversals, and at that point we're more prone to solar emissions or cosmic rays, or any sort of space-based menace.
Mm-hmm. All right. A couple of my members have exercised their free super chat. One per month. So Stringer News 1 says, this says I've been a member for 1 month, even though it also says that he's been a member for 9 months. So I'm not sure what's happening there. Yeah. Please, YouTube, explain. Dora and Koo, member for 13 months. Awesome. 1 month in a caption of this message, silly YouTube. Yes, I suspect there's some sort of YouTube problem there. So YouTube, if you're reviewing this, and I'm sure you will, please take note of that. I don't know who you report this thing to, but it seems like there's an issue there.
Yes. Well, I think, and I don't think that it's unique to your channel. I think that
no.
There's something going wrong. Yes.
So my next question, it sounded like you said Q1 Peninsula, and you showed a photo from your presentation that looked Q1. Okay. Can you show me that slide?
Yep.
And you said everything in there is not in chronological order. Can you explain why it isn't?
Okay. So this is the Huon Peninsula. Huon Peninsula is a very rapidly uplifting peninsula in New Guinea. It undergoes regular, quite significant seismicity that just uplifts coral terraces. And so if for instance, you're on a sea level low stand, like the middle of an ice age, for instance, and you're forming coral terraces, earthquakes can raise that quickly enough that it will outstrip the latest sea level high stand if sea level rises by enough. I think at some. Let me just get some more documentation on Huon Peninsula because it's been studied in great depth. So I'll stop sharing that and I'll pull out.
Daryl M used his free super chats. A member for 11 months. What? YouTube got something wrong? It's great to see all my members here. It's great to see them.
Yes, it is. And it's good to see people showing Hugh some support. So,
and I wonder why people like Clive Wells and Carl Williams aren't members.
Well, they're poorly paid academics. I think that's
it's their choice, of course, but I just want to encourage them.
Yeah. Okay. Well, just a second, and we'll get to. Okay.
So he's just getting to there. Oh yes, hang on. I've got to put it to the stream. Add to stream. There we go.
Okay, so this is actually not the greatest paper to have chosen because they're particularly fixated. But you can see in Aladdin's cave they actually found a coral that was something like 110 meters from its nearest neighbor, implying a change, or implying a change of sea level, somewhat larger than is realistically. So if you look here, Aladdin's cave suggests that there was a fall in sea level of the amplitude of 80 meters in a few thousand years, which is the ice sheet modelers would tell you that that's extremely implausible. So this was not the best paper to pull out. Curse me for trusting science.
Curse.
Yes.
What about the picture you showed to Gutsick Gibbon? Maybe that'd be more useful.
Yeah. Okay. All right. I'll get that.
At least it shows what we're talking about.
Yeah.
And then we need to understand why it's not in chronological order.
Okay, so if you can you see that?
Yep. So this is New Guinea.
So this is in New Guinea. Yep. Okay. So let's imagine that we're starting out with sort of hundreds of thousands of years ago. And sea level at that time was very, 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 very low. Okay, this thing gets uplifted slightly, but then sea level rises, and now sea level is above that old coral terrace. So there's a old coral terrace that formed when sea level was low. Suddenly sea level rises, and you've got a coral terrace forming at a higher higher on the mountain. So the higher one is older than the lower one, and then sea level can fall again, and you can get sort of coral terraces forming at all these different sea levels that are just on this. That are just on this mountain that is basically popping upwards at about 4 meters per 1,000 years or something like that. It's going at, what is it? It's 400 meters and it's about 500,000 years old or something like that. So it's going at about 100 meters every 1,000 years. So it's uplifting at a spectacular rate. And it's so every 100,000 years or so, it's uplifting by more than 100 meters, which is about the scale of the variation in global mean sea level. So you get these sea level indicators that are just forming everywhere and then just all being uplifted. And what you would normally expect is what you've got here. So here in California, you've got these marine terraces, but each of those represents an interglacial. So they're only the sea level high stands. So we're in an interglacial period now. So that's where the shoreline is today. If you move into the first one, which is sort of in the middle of the figure, that's about 120,000 years to 130,000 years old, that terrace there. Then you move back to the next one, which is about 250,000 and so on. And so these are strictly ascending. So as you go up, they get older. But because the uplift is so fast here, sea level is not just forming at the sea level maximum and being preserved. Sea level can form, sea level indicators can form when sea level is lower and still be preserved because the uplift is so large. So in the California example, it's not that there wouldn't have been marine terraces when sea level was lower. It's that those are now below sea level. You can't see them anymore. It's only the ones that are above sea level that you can still see. Whereas at the Huon Peninsula, because there's so much uplift going on, everything, there's just a mishmash of what gets preserved and what doesn't. And sometimes you get... Go on. Well, sometimes you get coral growing on top of other corals. So you get younger corals growing on top of older corals, but that younger coral might be forming when sea level is lower than it was for the older coral. It's just there's all sorts of, actually, I think I got that wrong. Sea level will be higher than it was for the older coral, but it's just a very, very complicated dynamic that needs to be untangled here.
Just to summarize, and I hope I'm getting this right, it was being uplifted, but while it was happening, sea level was going up and down, up and down, up and down. So that's exactly why it's a mishmash of things.
Yeah, exactly.
Right.
And okay. So you're just getting, and normally, sort of, as I say, normally you've got the current shoreline, and then older shorelines are probably below sea level. Most commonly, that's the case. So sea levels from 18,000 years ago. Well, I've got an example right here. No. Where'd it go? Oh, there it is. Okay. So this is the Bonaparte Basin, which is just off the coast of northwestern Australia, and you can see this depression here. But that depression is at a depth of it's now 110 to 115 meters below sea level. But it used to be above sea level at the last interglacial. So normally your paleo sea level indicators from 18 to 15,000 years ago, they're underwater. You don't see them because the water level has risen and it's just completely inundated the site. So oftentimes we don't have access to those, which is why the Huon Peninsula case is so remarkable, because we have a wide variety of ages and corresponding sea level values for these particular terraces. Of course, it's very difficult for us to link these particular terraces to any particular sea level because they're all uplifted and they're not in their original positions. But it gives us sort of some interesting data on the entire process.
Mm-hmm. And I guess this is the noise that you were describing in the video that all the other geophysicists would wish you'd make go away.
Well, the noise
Or an
that
example of it.
Yeah, well, it's one example of it, but the main thing is that this deformational process that I model, other people don't want included in their observations, but it is included in their observations. So when you're making a gravity observation of Antarctica, for instance, what you probably want to know is how much mass is Antarctica losing. But there's a gravitational signal because of glacial isostatic adjustment. So what the researchers want is for me to make that glacial isostatic adjustment signal go away, so that they can just look at the mass change in the Antarctic ice sheet. That's what I refer to when that's what I mean when I say there's what I model is noise that other people don't want in their signals. So yeah.
Mm-hmm. Okay then. Let's get back. I think I've got through most of my questions. I wanted to ask you about volcanoes. Have you ever done any research on volcanoes as part of what you do, or is that more a geologist than a geophysicist?
Well, volcanology is its own thing, but yeah, that is more geological. Though they do have their own deformational signals, actually. So you, for instance, a volcano on a seamount, as it produces lava, flows up through it, and that increases the mass that is being applied to the surface there. So you will get a deformational signal and a gravitational signal due to this effect, which does remind me of sort of something that I did want to touch on, since we're all flat Earth debunkers here. So I wanted to share something. Just a second, and I'll get that paper isn't very good, so let me look at a website. But what was your question about volcanoes?
I just wanted to know what ones you've been to, because I'm fascinated by volcanoes personally. It's something I want to go and visit someday. I go to Vanuatu or something, and I thought it might be related to your field. That's all.
All right. Well, the one at Rabaul is the only one that I've been to, and that was shortly after the big eruption back in the late 90s, and that actually was for a GPS survey of Papua New Guinea. So that would have been actually. That would have actually been another place that I have been as far as work is concerned. So, yeah, It's...
Stringer News 1 asks a good question. What do they call volcanology on Romulus?
I have to admit to not knowing the answer to that question, so I'm going to leave it... just going to leave it as an exercise for the listener. So, yeah.
Yes, I can imagine a few things. Maybe we shouldn't mention them. Given Romulans and Vulcans are supposed to be very similar, so maybe it's like an OnlyFans for Romulans. They look at Vulcan women or something like that.
Okay, so
I can't think of anything funnier, but anyway, yeah.
Well, I'm busy sciencing here in the background. So, okay, here we are. I'm doing high IQ research. That's what's going on.
I got tabs open. Okay.
Yes, I got tabs open. I don't want. Go away. So this is something that is often used. If you look at a map of the Earth, you will often see that we plot where the mountains are on the ocean floor. And the question often arises, how do you know where the mountains are underneath the ocean floor? You can't see them when you fly over them, so how do you do it? And it turns out that the because the mountains are denser than the water, they produce a positive gravitational anomaly. So it actually causes the water to sort of pile up over the mountain, as shown in this diagram here. And so this is actually detectable using sea surface altimetry data. So, so these lumps of water caused by the gravitational attraction of the ocean floor mountain are how we one very important data set in how we map the ocean floor. So what you do is you go out and you spot check. I don't know if they've got any other images here, but you sort of spot check that against actual sonar soundings. So you send some craft who are sailing by will take sonar readings of the ocean floor as they're going past, but that isn't particularly common. And most of the data comes from this sea surface altimetry, which we can turn into ocean floor bathymetry using our theory of gravity. So when people say, well, have you got any evidence of gravity working on water? Well, yeah. Have you never seen a map of the ocean floor? Because the way we get those maps is by using gravity.
Yep. And it works every time is the point.
Yes, and it works every time.
We'll get on to Rachie soon, but yeah, she was basically doubting that when talking with FTFE earlier today.
Yeah,
Australian time at least.
Mm-hmm.
Yeah, I think it was late night UK time or European time. Just let me finish off my questions and then we'll move on to that, I guess. So you actually showed the image for it, but we didn't really talk about it. Drop stones. Explain what drop stones are, and then I'll make my point about it.
Okay, so drop stones are chunks of rock that have been sort of ground off the. They've been lifted off the ground. They're embedded in the ice sheet, and then as the ice sheet gets towards the water, icebergs drift off with these stones embedded inside them, and they melt over time, and they just drop the stones into that mud. So you can call them drop stones. They're often called ice rafted debris. So yeah, that's all they are.
Yeah, and I thought it was a fascinating part of your presentation to Gutsick Gibbon. So I'd never heard of drop stones before, and it's a fascinating idea. And it made me think with FLIRFs, they say, oh, you've got to trust your senses and what you observe. But with drop stones, we're talking millions of years, basically, aren't we? The glacier has to form first. It has to grind off the rock. Then it has to flow down the hill, which could take thousands of years. And then it has to become an iceberg. And then it has to drop it into some silt somewhere.
So generally thousands of years would be the timescale that we're looking at for the formation, transport, and deposition of drop stones. Yeah.
But the point is, if you just look at the world by what you could observe, you would say, no force could ever pick up a rock and take it somewhere else. Yet drop stones prove that that's not the case. If you give Mother Nature enough time and the right conditions, it can pick up a heavy rock that you couldn't possibly move, and take it somewhere else.
Yeah. So there are a number of sort of technical points to be made about that entire process, because when we talk about a glacier sort of lifting up, that can happen sometimes, but it's you can also get rocks that have just been sort of gouged out from a cliff face or a mountainside. So they've fallen into the ice and then being carried that way. And so you can. There are a couple of other mechanisms by which the rock never actually gains any altitude. So it's always sort of gravitationally going downhill. But then sometimes the glacier can be assisted because there are there are some regimes where it can exercise mechanical advantage. For instance, if you've got a long, thin rock, but its end gets stuck against another rock, it'll sort of flip up and end up in the ice stream like that. So there are various ways to explain how these rocks get suspended in the ice, per se, and some of them do involve lifting, and some of them just involve sort of stuff, just dropping into the ice stream. So it goes in multiple ways, but there are many ways to skin a cat. The fact is that it happens, and we see it happening. So I guess in that sense, I'm just relying on the trust our senses argument. But yeah.
I mean, you see a big boulder and you would never think that it'd ever move anywhere, but obviously it does. Given enough time and given the right conditions. You also you sort of mentioned it and then moved on. I was interesting to explore this a little bit. You mentioned that there are perturbations to Earth's gravitational field. So I speculated, in my head at least, that there's two reasons that could possibly happen: the movement of the planets and the sun, and the mantle moving about. What were you getting at there? What causes perturbations in the Earth's magnetic field? I'll get it out eventually.
In Earth's magnetic field, or in the ice?
The gravitational field, sorry. Yeah.
Sorry, the gravitational. So perturbations in Earth's gravitational field result from basically mass redistribution. So as you say, mantle flow is one of the mechanisms that's internal, but also redistribution of surface mass. So in glacial isostatic adjustment, you have to consider the gravitational attraction between the ice sheet and the ocean, between the ocean and itself, in order to get the right answer, in order to get a physically consistent right answer. And this leads to sort of one of the counterintuitive results, which I always trot out to people who are new to this subject. If you've got an ice sheet sitting on the coast and it melts, then sea level next to the ice sheet will always fall. And the reason for that is that the reduction in gravitational attraction of the ice is always bigger than the amount of water that you've added to the oceans. I've got a cartoon of that, so why don't I show it? But it's one of those counterintuitive results that doesn't seem to make physical sense. But when you sit down and you run the numbers, it actually works. And I've had physicists tell me that it can't be right, and they don't believe me. So no, that's not the one. Here you go. So you can see in the sort of panel on the left that there's what we call a direct gravitational effect between the ice sheet and the oceans, but there's also an indirect gravitational effect due to mass redistribution inside the mantle, and you need to include both of those. And when you're doing the calculation, you need to include both the direct gravitational, the change in the direct gravitational effect, and the change in the change due to internal mass redistribution. So that's what I meant by gravitational perturbations, and you get rotational perturbations as well, and those impact sea level because they affect if you rotate the Earth, then you're changing the distribution of centrifugal force, so you're changing sea level as a result of that.
So yeah, more proof of rotation, basically.
Yeah, exactly.
You also mentioned something, I didn't quite understand it when I heard it. You're talking about something that had an extra galactic source.
Yeah, cosmic rays.
Yeah.
So cosmic rays, some cosmic rays are produced by the sun. There are many cosmic rays that are produced inside the galaxy, and then there are a lot of cosmic rays that are produced from outside the galaxy that are presumably quite old. I'm not an expert in this, but yeah, that's what I read. So I'm willing to take it on faith. I don't see any reason why they should be lying to me about the makeup of cosmic rays. But yeah,
But I think the context was the isotopes that we find in rocks and things like that.
Yeah, but that's really independent of the source of the cosmic rays. The cosmic rays themselves are, just highly energetic particles. So, it doesn't matter if they're extragalactic or intragalactic or solar, really. They'll still have the same effect on rocks. So it doesn't, but yeah, those rays entering and hitting, the atoms, like I was showing earlier with the production of beryllium-10, if you've got a high energy proton hitting oxygen-16, or a high energy neutron, that would have been, or a high energy neutron hitting nitrogen-14, you can get carbon-14 out of it. So these. It's a reasonably common event, and some of the cosmic rays that do this are from outside the solar system and from outside the galaxy even. Okay
then. I think that exhausts my questions about your Gutsick Gibbon video. I would recommend everyone to go and have a look at that. There's a link to it in the description, or you could look up Gutsick Gibbon as a channel on YouTube and you'll find it. Tony and Erica had a good old chat. In fact, I was surprised it didn't go for longer, to be honest, because it felt like you only just brushed over some of the subjects that you talked about, and you could have talked for many more hours. And that's why I wanted to do the live stream, to give you a chance to talk more about it.
Okay, well, there's, I can talk underwater with a mouthful of marbles. Just 50% of what I say is going to be but it's, it went surprisingly quickly. But it was still an hour and 20 minutes. So, perhaps more than mere flesh and blood can withstand. We'll see.
I watched it on at double speed, and it came across quite energetic. So, yeah.
Okay, well, that's probably the way to do it. That's a good technique.
I can still understand what you were saying. I couldn't hear, her volume was very low, actually. So,
anyway,
that's just the way it was.
Common complaint. So
yeah, I could hear you quite clearly though, which was good because you were the guest. We should be hearing you clearly. Yeah. If you don't mind, we might touch on the interaction with Rachie today, who had her last chance with FTFE on a so-called debate. I didn't do that.
No, I misclicked on the buttons.
Yeah, so FTFE is trying to help her understand all the misunderstanding and the brainwashing she got from dumbasses, basically. I would have thought if you're going to choose someone to brainwash you, you don't choose dumbasses, you choose people who know what you're talking about, who will know what they're talking about. And I think that comes to flat earth and reality deniers and conspiracy nutters in general. They reject the advice of people who know what they're talking about because they're experts and they spend their whole lives doing it, in favor of complete idiots who know nothing about it. And that's the fundamental offensive position that just makes no sense whatsoever.
Well, many people picked earlier in the early in Rachie's career that she was solely in it for the attention, and I think that they're exactly right in saying that. I don't, she continues to dangle the possibility that she might be a convert, that she can be reached by reason or evidence, but there's absolutely no evidence that that's the case. And she's, as I pointed out this afternoon, she has received many dozens of hours of time from highly qualified people like myself and Phil Bell in particular, Clive Wells and Joseph H. to a lesser extent, But our services as tutors amount to a couple of $100 per hour. Phil has dedicated several videos, 10, 15 minutes a pop, that I would imagine take at least an hour or two to produce. That's $400 worth of tuition for Rachie's benefit, and she isn't the least bit grateful. She isn't the least bit respectful. She's very free with her allegations that stuff is just made up, that she's under no obligation to believe it unless somebody comes along and demonstrates it to her in her own lounge room. And to be brutally honest, fuck her. If she wants to wallow in ignorance for the rest of her existence, have at it, Rachie. Can't think of anything. Well, I can think of a few people more deserving, but they're already doing it too. So you and Anthony Riley and Nathan Oakley can, wallow in your self-imposed idiocy, and I hope you're as happy as pigs in shit.
Which is an apt metaphor.
Which is very apt metaphor, right?
Yeah.
And I think there's a and I really would not. I would not encourage anybody to engage with her. I would not encourage anybody to talk to her. She's beyond any hope of conversion. What she's in it for, the reason she appeared on FTFE was to drum up interest in people going over to her channel and interacting with her videos there. And I just advise everybody to forget about her.
Yeah, I'm planning on this being the last mention of Rachie on my channel, and I would encourage every other channel to just ignore her from now on. If she shows up in the chat, give her the Vicky treatment, because she's had her chance and she didn't take it. So that's her choice, and she should live with that choice. But I think other people, yourself and Rumpus, made some very good points in that live stream, and I'd just like to play those. I'm sure FTFE doesn't mind me playing it.
Okay.
So just let me share that. StreamYards make this always makes this difficult. Anyway, let's try and do it. Okay, here we go.
This is the gravimeter. Can you see that?
Yeah.
So this is the gravimeter that I help maintain. It's a superconducting gravimeter. It's full of helium, and it's super cool. It's maintained at a temperature of about 11 Kelvin.
Oh,
and
I didn't realize we could get things that low.
This is actually quite old. You can get sort of down to fractions of Kelvin nowadays.
Wow.
But that's yeah. So that's just a video of that. You will notice that there's a bunch of electronics there off to the left. Those are not actually the instrument outputs. The instrument outputs are actually outside this room. This instrument is kept in a basement at the local astronaut. We have a school of astronomy. It's kept in the basement up on the mountain there. And just us being in the room with it is enough to completely disrupt the instrument. It is so sensitive that being near it and moving will disrupt the instrument readings. So it is physically impossible for me to move an item up and down near it and get a picture of the response in the main room, because the main room is about 5 yards from where I was. Even if I could get an instantaneous reading of what was going on, the fact that I'm there would be causing the machine to spaz out. Basically, we have to go in, do our maintenance, and then we have to leave it there alone and be nowhere near it, because our presence is enough to disrupt it. So I help maintain it. I have access to it, but I'm not in charge of this project. It's not my gravimeter, and it is not at liberty to be used for stupid YouTube demonstrations to make up for the fact that somebody else can't be bothered to learn basic high school science. That's not what it's for. I don't get to disrupt its scientific application just to make you happy, Rachie. So no, I couldn't do what you asked. but there are very good reasons why I couldn't do what you asked. So how about you find somebody with access to a less sensitive gravimeter and ask them? And instead of spreading lies about whether or not I have access to a gravimeter or whether or not I can demonstrate gravity, I've published 3 papers in the past 2 months on Earth's gravitational field. And I'll thank you very much not to go casting what are basically fucking lies about me and my colleagues. I can't do the demonstration that you want. It's a stupid demonstration anyway. This instrument is far too sensitive for that sort of thing to pull off. So pull your head in and learn how to read. You know why you can't find YouTube videos about science? Not that you believe YouTube videos about science. Blue Marble Science did an extensive YouTube demonstration of his Cavendish experiment, and you called him a liar and a fraud to his face.
Yep.
No, I didn't know who was lying.
Yes, you did.
Yeah, you
No,
did.
I
You
didn't.
called it a part of.
Show me where I said he was a liar and a fraud.
You did.
Next
You
video, I expect
did.
you to show a screenshot or whatever saying that I said he was a liar and a fraud. That's not what
I can
said.
do that.
Lying
I can
to
do
the
that,
eyes.
Rachie. I can do that because you told me personally
I
how.
told you it was a parlor experiment.
Yeah,
That
so
is
you
not
are
me.
calling him a liar. So you are calling him a liar.
You know what,
You are
FTFE?
calling
Go
him
fuck
a
yourself.
liar.
I think that gets the point there.
Yes, it does. I was
so-
I got no time for Rachie's intellectual dishonesty, and perhaps she's too stupid to genuinely understand what the term parlor trick means. But she is, for all intents and purposes, calling Blue Marble Science a fraud and a liar. And I just it's I'm done. I'd have no patience for her anymore. She's grotesquely ill-informed, intellectually bankrupt half-wit. Everybody talks about how she has intellectual ability. It's limited. It's very, very limited. She has limited capacity for abstract thought. She's not as staggeringly stupid as many flirts are. She's no Arwen, for instance.
Sleeping Warrior. Yeah.
Yes, Sleeping Warrior. I would place above Arwen intellectually, but it's a close run thing. But the sheer intellectual dishonesty, like she was asking for video demonstrations. Given a video demonstration, she accuses it of being a parlor trick, and her argument that it was a parlor trick where Blue Marble Science didn't know it was a parlor trick. Well, that's not a parlor trick, is it? That's not a parlor trick. When was the last time you saw a magician who was doing stuff he didn't understand? Right? That's not how magic works. Lackwit troglodyte, I could have gone there, yes.
Yep. I just want to mention Truth Nerds used his free super chat as a member for 11 months. My new favorite Krakatoni moment. Well, I think there's a better Krakatoni moment later in this video, but I'm not going to play it today because I feel a little embarrassed, Tony. I think he sort of regrets going that far, but yeah.
No,
He called her a bee.
Yeah, and she deserved it.
I don't doubt that, but you're generally a nice guy, and it's not the sort of thing you sort of do a lot. Put it that way.
No, it's not the sort of thing I do a lot, but I was, there was a lot of provocation, and this is one of the things. This is one of the things that I think is underappreciated. Is that I mentioned before that Phil Bell and I dedicated a lot of effort and a lot of time, free of charge, with no conditions attached, to trying to educate her, and her response has been to not only ignore what we've been trying to teach her, willfully ignore and resist being taught. She's responded with basic insults, insults at me and at my profession. And if you're going to go around saying insulting things about people, you're damn straight I'm going to insult you back. and you can live
Especially
with
when
it.
you have no basis for it.
Yes, especially when you have no basis for it. So,
Because I think the thing that Rachie in particular epitomizes is that she's basically saying all these people who are actually experts in their fields, she's saying they're wrong based on nothing. And yet,
yes,
she adamantly says that, yes, I'm still right, even though I've got no reason for believing that I'm right. This is Rachie, that is. And then all the experts have been working on this thing for 30 years or whatever are wrong. It just makes no sense, that point of view.
Well, it particularly makes no sense because she's willing to accept other science. She's just, as she was asked about other scientific advancements, did she need those experiments done in front of her? No, she didn't care about the rest of science. It was only this one that she wanted done. And you're just going, let's say you're just making up excuses at this point not to accept the data you don't want to accept. That's all you're doing.
Standards of evidence. Yeah.
Yeah. And like if I perform a charitable act for somebody, okay, they don't need to appreciate it. They don't need to enjoy it. They don't need to like it. But they're certainly not going to get any slack when they turn around and insult me over it. I mean, I'm not going to yell at Gary Wybenga because, I have nothing but pity for this individual. But I've never really made any effort to try and educate Gary in the way that people have made an effort to try and educate Rachie. And eventually you just get kicked. Eventually you just get kicked and you go, okay, well, now you're just going to get, we tried doing this the easy way. Now we're going to do it with no pleasantries whatsoever and see if you enjoy it.
Well, no, I think we just ignore her and she becomes irrelevant and she realizes she's not going to get the attention she wants and buggers off.
Yeah, that's exactly
the way it should be. So I thought later on in the stream, the Rumpus made a very good points, I thought, which will be particularly helpful for people on the fence between flat Earth and globe Earth. That's, for me at least, I can't speak for you, Tony. One of the main reasons I have a channel at all is to help those people understand the reality behind the things that they see from flat earthers and why the flat earthers are wrong. It's those people on the fence that I'm trying to reach more than anyone else. Obviously, the entrenched flat earthers like Taboo Conspiracy, they're never going to be turned because they're making money out of it. And why would they bother seeking reality? They're not about truth. But those who actually are about truth, I'm hoping that we can reach those people. And I think the Rumpus made some very good points in regards to Rachie that are worth listening to. So let's have a listen to that.
If this is all useless, why do I get paid?
Tony, if you were to give a demonstration to Rachie, if you were to get in that room and then say, Rachie, I'll do anything you want me to do to demonstrate it, presumably you'll just end up showing her a number on a monitor that she'd then have to be able to understand, have it explained to her slowly. It would be absolutely useless to show her a demonstration of this at all. And that's why we write papers, to summarize it in a clear way to people and document it. Yep. And the idea that Rachie seems to have, that all experiments have to be all ready to go this second, every experiment she's ever interested in, there has to be someone hovering over a machine to demonstrate it to her, is insane. In science, we document things, so we don't have to keep all the kit occupying all the laboratories around the world. We do it once, we document it, other people test it, verify it, check it in other institutions. They then agree, yeah, everybody seems to get the same results. They then write that down and they present it in English in a nice, digestible fashion in a couple of pages, so that you don't have to spend 10 hours watching a video and have PhD Tony explain to you how a machine works.
Yeah, that's exactly right. I will defend Rachie a little bit here in the case that you do need to make care, and science has gotten a little bit sloppy about this, to make sure that what you're writing about is completely reproducible. There have been problems with code, with people not sharing their code, not sharing their data sets. So we have had some problems with reproducibility, and we have had some people in scientific literature, not in my field, but in other fields, who have just blatantly fabricated their results. So there is room
Andrew
for caution.
Wakefield.
There is room for,
That's peer review, isn't it?
well, these frauds got through this particular fraud I'm thinking of, Henrik Schahn, he got through peer review multiple times.
But
Peer
not
review is
eventually.
perfect.
But he got caught in the end by.
Yeah, he got caught. He got caught eventually. But one of the problems with peer review is that it isn't set up to consider the idea that a scientist is actually just bullshitting, right? That's not the first go-to. People tend to say, "Oh, well, he made a mistake. He's overlooked this. He needs to refine that." And as long as they do all these things, the reviewers are generally happy. But science is not a perfect mechanism, but peer review is the best way we've got of advantage. And as you say, you document everything, you write it all down so it's fixed, it's inflexible, it's immovable, it's right there in black and white, and anybody can go and read it.
And then, of course, by documenting it, you then give the opportunity for someone else to come along and reproduce this and invalidate it. Because, of course, someone can, and then say, sorry, that document you produced was bollocks. And it's not people like Rachie just wandering around. There are people who've got their careers in trying to invalidate everybody else's papers. They're trying to make a career and a name and a Nobel Prize. If they could invalidate the sorts of things that Tony's doing and saying, you've got your whole physics wrong, it doesn't work, it works in this different way, they'd be on for a Nobel Prize. It's in the interest of science to invalidate the previous work, and people bang their heads for years and careers trying to do exactly that. And also, earlier on, we were talking. So quickly on another point, Rachie, you were saying that science is just experimentation. There's science. You actually quoted it correctly, as I believe is a good definition of science: is the study of the physical and natural world, and you do that through observation and experiment. There's some parts of science that are just pure observation. So, for instance, the structure of a tree, your bodily functions, the heart, the mass of a proton. The stars in the sky, where they are and how they move. These are just pure observations. There's no experimentation involved, pure observation. And that is science. The mass of a proton, determining it accurately, is science. People have careers in science and publishing in scientific journals what the mass of a proton is. We've had recent discoveries about what is, or the mass of an electron. Mass diffusion, how atoms, pictures of atoms. These are just observational stuff. There's no experimentation. There's no wiggling some independent variable. You're just trying to find some way, although you do indirectly have to wiggle things, but you're not doing it to get an effect of the electron or the mass to change an electron. You're just trying to observe things, and that is a fundamental part of science. In fact, I would say it was the majority of science is making observations of things and documenting them.
So he did really well there, the Rumpus, I think. So
yeah, he did.
Yeah, explaining it. And I think if you're on the edge between what's real and what's flat Earth, basically, and you heard that should probably help you, I think.
Yeah, I think that there's a lot of misunderstanding about what science is. Sorry, I just got myself confused. I was thanking somebody who isn't in the chat. Just because something gets past peer review and makes it into the literature doesn't even necessarily mean that it's right. Because it may, there may need to be a retraction, there may need to be a correction, there may need to be, there
New data comes along.
Yeah, there may be some subtle problems with the techniques you're applying. The scientific understanding of a particular, scientific understanding is this kind of nebulous thing. Scientists generally agree on where we are, but there is fuzziness there. I have opinions about things that most of the rest of the people in my discipline, not all of them, but most, won't agree with, and that's fine. But it's only what I can get past peer review that counts for anything. But even if I get something past peer review, that isn't the final word. There will be other papers on this subject. There will be other discussions of these issues. And what eventually, there's no end, there's no finish line. You don't end science by getting it. Well, there's nothing left to discuss now. It's a constant refinement and advancement of what we know, building on what we know previously to learn something new. But I don't think that the general public have a very good understanding of the techniques and of the practicalities that are involved, and they kind of think the peer review is just this very chummy sort of process, and it really isn't. It's very cutthroat. People, you can end up on in some very bitter disputes. I mentioned earlier I had 3 papers published in January. One of the reasons for that is that we've been working on these papers for a decade, and we've been trying to get them published for the 3 years, the better part thereof. And the first time we tried, because we're new, my group is new in the subject of analyzing satellite gravimetry data, and so we said, look, here's this new way of doing it. Isn't it fantastic? We can achieve this resolution. And the reviewer said, anybody who knows what they're talking about knows that you can't do this. What these people are suggesting is nonsense. And eventually we had to sort of wait until some of the NASA people came over, checked out our methodology, and then tried doing it themselves, and then showed that it worked. And then after that, we had to wait for we had to represent the papers and get everything done, because the peer reviewers thought, well, they're doing it differently to everybody else, therefore they can't be right. And it took years to sort of convince review panels, the people reviewing our papers, that actually this stuff can be done. And we needed to get somebody who was already reputable to do it and present it at a NASA science team meeting. It's science. The peer review and publication are not easy. They're not trivial. You can just get slapped down and rejected. And you don't get a say in it. Once they've decided, look, once the reviewers have come back and said, well, this can't be done, and these people obviously don't know what they're talking about, the editor's just going to go, well, okay, you guys are done. Go away and do it. And it's kind of we were stuck. We were absolutely unable to get anything published because nobody believed that we could do what we were doing.
Yeah, and so science is self-correcting in that sense, because it'll make sure that no bullshit gets through. Anything that is new but valid will take a while to get through, but it'll still get through eventually.
Eventually,
and that's what's important about it.
Yeah, eventually it will. And I mean, I'm not, this is just the way science is, and that's fine. But people, and science should be resistant to new suggestions. We shouldn't be leaping on every fad that comes along. We should destruction test new ideas and see whether or not they stand up to rigorous analysis. To
me, the whole point of science is to provide an objective way to look at the world. That's what part of the process of review is. That it makes sure that it removes all the emotion, all the things that people want to believe, and looks at just the hard data, the things that aren't affected by human emotion or human desires or whatever. It's just, this is the data. It says this. Therefore, that is objective, because it is the same for every human being on Earth.
Yeah, and I mean, it's flat earthers have this weird perspective. For instance, the Andrew Stoll has just mentioned, the Russians would have easily been able to prove that the US did not land on the moon, but they didn't. They didn't make that claim. Because they knew that actually the US could prove that it had been to the moon. And similarly, when the first man-made craft ever to make it to the moon was called Luna 2. It was a Russian craft, and it was specifically equipped with a canister of sodium. And the idea was to explode the canister of sodium so that it would be visible from Earth. And their reason for doing that was precisely so that they couldn't be accused of fraud, so that they could have their have the fact that their craft made it there independently verified from by Earth-based astronomy. So this whole this whole argument that it was entirely a fraud. Well, they took specific steps. The Russians took a specific steps to make sure that they couldn't be accused of fraud, to make sure that it was clearly visible to anybody who wanted to turn a telescope towards the moon and do the appropriate analysis. Don't know what Gary.
Heaps of amateur astronomers around the world and ham radio operators as well filmed the third stage re-entering, filmed the second stage firing off to send them off to the moon. They were able to track it all the way to the moon and around the moon, and they were able to intercept the conversations the astronauts were having with Houston. It wasn't secret or anything like that. It was all happening, and they could from the time delay they could figure out how far away they were. It was all verified at the time. The only reason there's any dispute now is because most of the people who claimed that it was a hoax weren't even born back in 1969, whereas people like you and I were, and we saw it on television, and we were aware of all this thing happening at the time, even though we were children at the time.
So it's the and as Daryl M points out, there are retro reflectors on the moon. There's it's bewildering the amount of stuff that you need to sort of throw out in order to entertain the flat Earth fantasy.
Yes, Clive Wells, sodium is the major cation. You saw that guy on MC Toon, didn't you?
I don't think. Well, I saw a bit of him. There was something about gravity waves in ice, and there was another. And that's a bit unfortunate because the phrase gravity wave means something very different when it's applied to a physical medium than it does when it's applied to LIGO or something like that. And but it was. I understand that was the guy who was talking about cations. He was also talking briefly about blue ice and that sort of thing.
And canyons.
Well,
the thing I love was when he was trying to talk to Toon and as if he didn't understand what ubiquitous was. And as if, hey, look, it's ubiquitous,
yes. I'm
not pronouncing that 100%, but you know what I'm talking about.
Ubiquitous.
One of those words I don't say very well. He didn't even he clearly didn't understand what it was, but he was trying to impress on Toon this is a word that Toon couldn't possibly understand, so therefore you must respect me. But the fact is Toon did understand it, so therefore he didn't respect him. And FLEFs don't seem to understand that arguments that work on dumbasses don't work on people smarter than you.
Yeah, well, part of their problem is I don't think that they understand that there are people smarter than them. Certainly, I don't.
Well, they can't understand that.
Yeah, that's right. And I don't think that Rachie understands the limitation, her own intellectual limitations, on any level. I don't think Gary Webenga understands his intellectual limitations.
Certainly, Sleeping Warrior.
Certainly, Sleeping Warrior. Sleeping Warrior is fascinatingly candid in his belief that he is every bit as intelligent and well-educated as I am. He'll condescendingly tell me that he was in exactly the position that I was. Well, no, Anthony, I was never that stupid, and I was never that ill-informed. So I was never in the position you were in.
Yes.
So it's, but he says it. He said it repeatedly. Anyway.
And I think it's a good thing for a lawyer to have an ego. But when that's all there is, that's a problem. And Anthony Riley is the living embodiment of that problem. Anyway, so you had a big day. You had the Gutsick Gibbon interview, even though that was recorded, but you know what I mean. And you had the run-in with Rachie on FTFE. But I think your single talent is that you have the ability to express what everyone else is feeling, Tony. And as a result of that, I want to share this. So let's go.
You, sir, are a fucking idiot. You are a fucking idiot. You're a moron.
You just said that so well.
Well, I knew I was going to get kicked in an instant, and I'd been extremely polite on that stream. I'd granted him all of the courtesy that I felt that he was due, and he still muted me without warning and started talking over me. And so it's just a sometimes I think you just have to tell it how it is. And a lot of people are very unhappy with the fact that I yell at people. Well, if I thought that being polite to them was going to get the message across, then I'd be polite to them. But,
and you are mostly.
And I am, I spoke with Gutsick Gibbon for, nigh on, 90 minutes and didn't yell at her hardly at all. So, I can rein it in when I'm talking.
But she wasn't a fucking idiot, of course. But yeah.
Yes, she wasn't being a fucking idiot. So it would have been harder if I'd been talking to Standing for Truth or Kent Hovind or the Matt Powell or any of those idiots. But yeah, it's just I'm not going to treat somebody politely when, in my opinion, they're vandalizing the conversation, when they're being completely intellectually dishonest and an idiot to boot. Then I'm going to just yell at them, because you don't correct a child's behavior by and a child's egregious behavior by constantly treating them as though what they're doing is reasonable. Sometimes you have to just let them know there's a boundary there. But anyway,
I think it's more than that, though. I mean, a lot of people say that you resort to insults when you have no argument, but I think also you resort to insults when you've given them the argument and they still are stupidly rejecting it for no reason whatsoever. It's the fact that they have no basis for rejecting it is what makes them idiots. And then they give you permission to call them idiots, basically.
Well, that's certainly what I consider, and I think that I think that there are a lot of people who are obsessed with the form in which an argument is presented rather than the content of the argument. And I think that that's an intellectual mistake. It doesn't matter what a person is wearing. It doesn't matter how the person is speaking. You need to listen
the color of their skin or anything like that.
The color of their skin or anything else. You need to listen to what they're saying and the content of their words. And even if they're liberal, even if it's liberally sprinkled with coarse language, you need to actually process it and see whether or not it's communicating anything of merit or not. I'm not sure if you ever heard Tim Minchin's The Pope song. But it's a classic example of what I'm talking about. It's chock-a-block with foul language, but it nonetheless communicates a very pointed and worthwhile message. And it's And part of the message that it's communicating is if you're offended by the language I'm using and not by the actions of the Catholic Church in concealing pedophilia, then your priorities are so skewed that you're not worth talking to, right? And it's a great point, but it is something that people instinctively persist in, and I do alienate people when I do lose my temper. But sometimes I lose my temper just because I lose my temper. Other times I lose my temper because this person is being willfully ignorant. In particular, if I feel like I'm taking time out to explain this because I understand it, and this other person is just going, well, screw you and your understanding. I'm here to vandalize that and stop there from being any coherent discussion whatsoever. Then I'm going to let them have it, and I'm not likely to change at this stage of my life. So everybody's
And
going
nor
to have
should you.
to.
That clip I played, I think that's when you became a legend, basically.
Thank you. You're very kind.
Yes. It's like I said, you say things that we're all thinking. That's for sure, and that's good.
Yeah, I don't have the filter sometimes to. I think that what I said to Rachie earlier today was what a lot of people were thinking, but were too polite to actually say. So anyway.
I wouldn't call her a B personally, because I don't really call anyone a B, I guess. But yeah, it got to the point where it was clear that civil discourse was pointless. It wasn't achieving anything. Yeah. It wasn't helping her, which was the purpose of it. So at that point, you sort of give up.
Yeah, I think actually, Craig could have pulled the plug on her somewhat earlier, because I think she'd made it clear that she wasn't going to respond to reasoned argument. She wasn't going to respond to an explanation of why I was deeply offended by the way she behaved, and she didn't take any personal accountability for it. And I consider that to be the sign of a reprobate.
Well, the thing that got me is she seemed to accept that there were valid arguments against her position, but she would just make excuses against them, which had no basis in themselves. And that's just intellectually dishonest, and I just can't abide that. If you're not going to be intellectually honest, then what's the point of talking to you? It's like, that's why I don't respond to Gary Boybenga, for example.
Yeah, I mean, you do need to sort of pick and choose. One of the things about Gary is that he's never come across as sane enough to understand arguments. And I mean, again, Clive Wells made a video dedicated specifically to addressing a video that Gary had made and explaining why it was incorrect. And Gary watched the video and claimed that it backed him up.
Yes, they just twist reality to suit themselves, don't they? They don't look at reality as it is. They just see what they want to see.
And I mean, at that point, it's like, so, we're not in the same reality, right? That's and it's no point getting angry at Gary. Yeah. It's probably not his fault that he's crazy. It just happens to people. But I do feel like some people who are putting on a pretense of rationality, a facade of rationality, like Gary,
Nathan Oakley.
Nathan Oakley. It's a whilst they are in fact just being completely obstructive to any sort of intellectually productive discourse, I think that pulling the plug and letting them have it is entirely warranted. And I mean, it's, if we can't agree on what reality is and what constitutes reality, there's a real problem, and it's either my problem or it's your problem. If we disagree on perception of reality, either I've got a problem or you've got a problem,
or both is the other possibility,
or both. And one of the ways of checking that would be to go out and cross-check our perceptions against everybody else's perceptions. And if your perceptions are accepted as accurate by everybody else, I've got to go, oh, okay, well, I've got a problem then, don't I?
The other way is to look at objective data so that you remove all the subjectivity completely.
Yeah.
So it's not about perceptions, it's about what is reality.
And again, if you show me the data and I'm wrong, well, I've got to accept that I'm wrong. I've got to learn from...
If you're actually honest.
I was mistaken, but I can learn from being mistaken. I can now move forward and I can have more... better understanding of myself and my surroundings, having learnt something through being wrong. And flat earthers have a problem where they're unwilling to accept correction on any level. They don't accept data. They don't accept the weight of scientific opinion. They don't accept they don't accept the authority of science that has produced, the technology we're using to have this conversation, the electricity that lights and warms our houses, the technology that transports us and our goods, our food, etc. The amazingly sophisticated society that we've managed to build. Technology underpins all of this, and this technology was produced by science, and now we've got people like Rachie, like Gary, turning around and saying, well, science doesn't necessarily know what it's talking about. Well, okay, you do it. You do something technical. You do something technical so that we know that you can do it. And no flat earther has ever achieved anything of any technical value. Absolutely nothing. Not one, not ever. And with a record like that, how can you have any confidence that your perception of reality is more accurate than the scientific, than the body of science, which has produced, frankly, marvelous advances in quality of life over the past 400 years. It's bewildering that you can look at what science has been able to achieve, and then turn around and say, oh, well, but they don't know what they're talking about and they're all lies. Well, yeah, but they can't lie about computers. If they're not lying about computers, why would they be lying about, how the screen on your phone knows which way is up, or your iPad or whatever. We know how this stuff works because we incorporate it into our technology. We understand it.
Yeah, and I think that's the essential. I mean, FTFE talked about the hostility towards Rachie, and I'm not sure he got it right, because to me the hostility comes from the fact that here are these fucking idiots saying that they know more than people who are experts, people who have worked their whole life to figure out what the relevant facts are to that particular field. And they say that these idiots think that they know more than those people. How could they possibly know? Because they couldn't have possibly absorbed as much information as they have, as the experts had. So, and yet they're there saying you're wrong, and they're not really giving a reason why or any evidence as to why you're wrong. And that's what's so offensive about it.
Well, I think that for me, what's offensive about it is the accusation of, I don't have any evidence that you're wrong, but you're wrong. And I've come across this with multiple flat earthers. They just refuse to accept, you say, well, what about Rayleigh waves? Let's look at those. Rayleigh waves are a type of seismic surface wave that goes from the point of the earthquake, goes round to the antipode, and then travels back to the point for a large enough. And it'll do this multiple times. So it'll go in this circuit, it'll spread out, converge on the antipodal point, and then return to the epicenter, and keep doing that for multiple circuits. There's only one configuration where that can work for arbitrary earthquakes, and that's a spheroid. So we can tell from this one data set that the Earth is a spheroid. Flat earthers don't care. They will simply tell you that that data set doesn't exist. They will simply claim, or it's faked, or its analysis is mistaken. They don't know anything about it. They've never looked at it. They've never looked at the data set. They've never looked at the physics behind it. They've never looked at the physical phenomenon. But they will tell you, without any investigation, without any background, that you are wrong, right? They don't know. They can't know because they haven't looked at the data. They haven't looked at the physics. They haven't looked at any aspect of this problem. But they will tell you that you're wrong. And you just go, well, fuck you then. Go ahead and live in the squalor of your own ignorance. Live in the filth of your own intellectual bankruptcy. Be my guest. Meanwhile, the rest of us are going to be getting on with something productive.
Absolutely.
That was you, Gary.
Gary actually got one thing right. If he's talking about Rachie, of course, professing themselves to be wise, they became fools. And that's exactly what we were just talking about. People like Rachie and sleeping dumbass, they're fools professing to be wise.
He's in a very religious propaganda mode just at the moment. He's spewing biblical aphorisms.
It's interesting how they do that without any concept that people like you and me know that well. Know all that well. So,
yes,
it's not like it's new to us.
No. Gary, I was a Christian for 30 years, and one of the things that suggested to me that I should stop being a Christian was that if God exists, he would tell people like you to stop lying. He clearly doesn't tell people like you to stop lying. I conclude, therefore, from the existence of people like you, that God doesn't exist.
Ipso facto.
Ipso facto.
So I'd like to end on a slightly different note. I think we've covered that quite well. If I just share this. So this is the thumbnail for this live stream. Is that the same outfit you wore when you got your PhD, Tony?
Yes, it is. In fact, that's
good. I got it right.
That's uncanny. You've got the right university. That's exactly. I think I was in a different suit. Obviously, I don't have that picture. My parents have that picture on their wall somewhere, I'm sure, or in a basement or whatever. But we have a very funny-looking bonnet that we wear for PhDs.
Yes.
That is exactly what I was wearing.
I can attest that. I don't know if you didn't get a master's, did you? You went straight to PhD.
No, I got an honors and then a PhD.
So I can attest, as you know, for your bachelor's, you have a mortarboard, and you have the same for a master's. It's just a different sort of robe that you wear, which I didn't really notice the difference from my bachelor's, but it had been 20 years in between. So I guess I wasn't going to notice a lot of difference. I like the idea. I made myself the chancellor wearing those robes.
Yeah, that was. You've done quite well, though. You're struggling a little to fit into that fit into the Chancellor's robe.
Well, the important bits are exposed. So
Yeah, that's true.
yes. All right. So I think we should wrap it up there. It's getting late where you are. It's certainly late, and yeah, you're an hour ahead of me. So I thank you very much for being my guest as always. I think this is about the 4th stream we've done together.
Yes, I think
I actually had the thought we'd do. Oh, it must be more than that because we did a couple of Kings and Queens ones.
Yep.
I was actually thinking tonight we might do the Saxon Kings one, but then this came up, so I thought this was more interesting at this point in time. So maybe we should do that next weekend or the weekend after, whichever suits you.
Right. Yeah, that would be fine. Either are okay with me, I think.
All right, I'll look forward to that.
Yep. Give me some time to do revision.
Yeah, why not? Because unlike first, we actually figure out, try to make an attempt to know what we're talking about before we start talking about it. Don't let him get. He's an idiot troll. Yes, fair enough. So thank you to everyone who's in the chat as well for coming along and listening to us talking about some rather highbrow type of topics, but it's been fascinating to me at least. If you found it fascinating, please leave a comment in the chat or a comment on the video itself. If you like this video, please click a like. In fact, I noticed there are 32 likes and 29 watching, so that's pretty good. Damn good ratio.
Excellent percentage.
Yes, I'd appreciate it if you could leave a comment in the video as well once we finish, and so that other people who come along and watch this. This would be a really good podcast to listen while you're driving to work or something like that. So that if you leave a comment there, that helps gets it into the algorithm and gets it distributed to people, so that they get to hear what we've talked about tonight. And I've had a good time. I appreciate you, Tony, being here, and I thank you very much for being my guest. And I look forward to you being my guest next week or the week after, whichever we figure out. And we'll talk about a different subject. But yeah, again, we're talking about things that we enjoy rather than necessarily looking for customers, I guess. Thank you to all the 30-odd people who've come and watched us. And I guess there's nothing much left to do.
There's nothing left to do but cue the corgi.
You're despicable.